Assalamu alaikum students. Welcome back to my channel CheMuneeb. Today we shall start with a Feb March 2025 paper of chemistry AS level, and it is paper 2 second variant. So let's start with this paper. The first question says phosphorus and chlorine are elements in period 3 of the periodic table. Chlorine forms 3 different compounds with phosphorus. The most common are PCl3, PCl5. So we have to complete the table by providing the oxidation numbers of phosphorus and chlorine. So we can see from here that chlorine is more negative as compared to phosphorus, and that's the reason chlorine is has negative oxidation number, which since it belongs to group number 7, it has -1. And from here we will find the oxidation number phosphorus. So if it is -1 for one chlorine and 3 times gives -3, then phosphorus will have +3 over here. And PCl5, it is -1 times 5 for chlorine to give -5, and phosphorus will have +5. So we'll write for phosphorus +3, or you can also write like this. And over here it is +5, or you can also write like this. And then chlorine is -1 for one atom. We have to write oxidation number for one atom. So it is -1 over here and a -1 over here. Both will have the same. Now, the second part of the question, in a closed system, PCl3 and PCl5 exist in an equilibrium. So we have to tell which two conditions will favor the production of PCl5, which means we have to move the equilibrium in the forward direction. So for this reaction, delta H value is negative, which means if we decrease the temperature, then it will move in the it will move in the exothermic side. In the forward direction, it is exo. And if we increase the temperature, it will move towards the endothermic side, which is on the left side. So here in this case, we need to increase PCl5 amount. So we'll need to decrease the temperature. So first we will say by decreasing the temperature, it will move in the forward direction to make more PCl5. What else do we have? The other condition, we can apply the condition of pressure. We can also apply the condition of the amount in terms of mole. So if we see here, it is a solid and it is a gas. This one is a liquid. When we apply the effect of pressure, then we consider gas over here, not for liquid and not for solid. Solid doesn't account for the pressure. Liquid is also not accounted for pressure, which means there is only one unit of gas over here. So 1 mole of gas is here, and there's 0 mole of gas in the product side. So if we increase the pressure, by increasing the pressure, it will move towards that side in which the pressure is low or the amount is low, which is the product side. So it will move in the forward direction if we increase the pressure, because there is no gas on the product side. So increasing the pressure will move the equilibrium shift towards the right. Moreover, we can also include the condition of the amount. You can also include amount. In terms of this case, we can see that there is we have chlorine gas over here. So if we increase the amount of the chlorine gas, it will definitely move towards the product side. So increasing, you can also include increasing Cl2 gas. That will also move toward the product side. The next question is 3. The third component of phosphoric chlorine W has a relative molecular mass Mr between that of PCl3, PCl5. The compound contains this much mass of chlorine. Determine the molecular mass of the W. So we are supposed to find another compound of phosphorus and chlorine which must have a mass in between of these two compounds. Okay, now we have provided this much percentage mass of chlorine. From this value, we can find the percentage mass of phosphorus. So 69.6% is that of the chlorine. Now we will minus this from the 100. So 100 minus 69.6 is equal to 30.4. So 30.4% is that of the phosphorus. It is percentage of the phosphorus. Okay, now we have the values of percentage masses of atoms. We will now convert these masses into their moles. So moles is basically is equal to percentage mass divided by the relative atomic mass values. So for here we will apply for phosphorus and chlorine. Phosphorus ratio chlorine. The percentage mass was basically 69.6 for we have 30.4 for phosphorus, and for chlorine we have 69.6. Now we divide these values with the relative atomic masses. For phosphorus we have the value of 31. For chlorine the value is 35.5. These are the relative atomic mass values, AR values. These are the AR values. Now the calculation will give you 0.98 ratio 1.96. Now these are their moles. These are moles values. Now we can see here that if we round this value, we will get 1, and if we round this value, we will get 2. So 1:2, which means the formula which we can deduce here is PCl2. Now if we look at here, we don't still know if it is empirical formula or is it the molecular formula. Which one of these is true? We are given the statement here that the third compound of phosphorus chlorine has relative value between that of PCl3 and PCl5. So if we calculate the MR value of this PCl2, I'm going to calculate MR of this value. It will be 31 plus 35.5 times 2. Now it is equal to 102. Now for PCl3, it will definitely be higher value. PCl3 must have higher value than PCl2, and the value of PCl5 is in fact highest. PCl5 will have highest value because all of them have one atom of phosphorus but multiple atoms of chlorine, which means that 102, which is the mass of PCl2, it is indicating that it is not the molecular formula. It is not molecular formula. It will definitely be empirical formula. We need to calculate the molecular formula, which means it must be multiplied. This formula PCl2 must be multiplied with some integer, with some multiplier. So PCl2, if I just multiply with the smallest number except for the 1, because 1 doesn't give any new number, we will definitely need to multiply with 2. That would only increase this value. So P2Cl4. Now I need to check the MR value of this compound. So MR of P2Cl4 will then become 31 times 2 plus 35.5 times 2. It is definitely multiplied. This one can also be said as to be multiplied by 2. So I have 133. Now it is 133, which is the mass. Wait, not with 2, it should be multiplied by 4. 35.5 times 4, 204. 204. Okay. Now, if I check for PCl3, 31 plus 35.5 times 3, it is equivalent to 137.5, and for PCl5, it is equal to 208.5. Now you can see that 208.5, 137.5. So this value, which is 204, it is in between 208.5, then 204, then 137.5. So we can now conclude that this formula P2CL4 is actually the molecular formula. It is a molecular formula, and previously it is a molecular formula. So it is basically the formula. So we will write P2CL4, whereas PCl2 was basically the empirical formula. Now, next question, part 4. W is a liquid at room temperature and pressure. It reacts vigorously with water to form an acidic solution. Suggest the structure and bonding in W. Explain your answer. All right, so if it is a liquid at room temperature, it means it will be a simple structure. By noting its melting point, this could be considered as melting point, which is the room temperature. So if it is a liquid at room temperature, it means it will be considered to be a simple molecular. It can be said as simple. The structure is simple molecular. And it says explain, suggest means you have to state the structure type and you have to explain why. Because because it has low melting point. Melting point is low. And then it says what is the bonding type. So those compounds which are simple molecular are definitely contains the covalent bonding. You cannot say ionic bonding, you cannot say metallic bond, because those are all having very high melting and boiling point. So covalent bonding is there, and why? Because it reacts vigorously with water. Because this type of reaction is said to be hydrolysis. So hydrolysis because it hydrolyzes. So reaction with water is also an indication that the type of bonding is covalent. If it is ionic bonding, we say dissolve. There is a dissolution of the ionic compound if the type of bonding is ionic. And if it is the metallic bonding, then there is no reaction between water and metal as such. Instead, and in fact, the compound is already a simple molecular, so a simple molecule does not contain the metallic bonding. So that's how we give the answer. Now, the next question is, we have this reaction. We have to give multiple answers to this question. Part 1 suggests what is observed in reaction 2. So reaction 2 is basically this reaction. What is observed? We can see here that chlorine is a gas which has a greenish yellow color. It is a greenish gas, greenish yellow gas. So the gas is now disappearing when it reacts with a P4 to make PCl5. So what we can see here, that green gas disappears. Then part 2, predict the shape of molecule PCl5. PCl5, if you remember from the chapter of chemical bonding, we saw that when a group 5 element bonds with 5 more atoms, if it is bonded with phosphorus is bonded with Cl over here, Cl over here, one Cl over here, another Cl over here, and another Cl over here. This type of structure is called trigonal bi bipyramidal. It is trigonal bipyramidal when the bonding is with 5 atoms. Now, the next question, part number 3, write an equation for the formation of A in reaction 3. So, formation of A, we can see here, this is formation of A. We have to write the equation. So, reaction is between P4 and O2. So, P4 plus O2. We should know that the product will be P4 O10, and you have to balance the equation by putting 5 over here. So this is the product which you will obtain by reacting with the P4. All right. Then we have name B, which is formed in both reactants 4 and 5. 4, reaction 4 and reaction 5. In both of these reactions, we have to write the name of the B, which is the product here. So if we see PCl5 is reacting with the water and A is reacting with the water. A, as we said, that it is P4O10, and this is PCl5 reaction with water. For this purpose, I need to take you to the literature from my notes. All right, so here that's from my AS chemistry notes. You can see there when P4O10 reacts with the water, it forms the H3PO4. Now that's one way to find the answer, but we need to check for the other reaction as well, which is the reaction between the PCl5 and the water. For that purpose, I will check that type of the reaction, PCl5 and the water. Okay, so this is the reaction between PCl5 and water. So again, you can see H3PO4. So in both of these reactions, we can find that PCl5 and PCl5 and P4O, and both are producing one single product, that is H3PO4. Okay, you would be thinking that we need to write H3PO4 over here. No, that will become incorrect. That is wrong. We have to write the name. That says write the name, which means we will put here the name, phosphoric acid. That's the name of this compound, which you should remember from your O-level knowledge. It is a phosphoric acid. And in some cases, they could be also 5 written inside the bracket. Now, part number 5, draw the structure of C used in reaction 6. Okay, reaction 6 is this one, and the structure should be indicated by C. Okay, now we can see that PCl5 is reacting with the C to make this compound. Now, which could be the organic compound over here, which will react with the PCl5 to make this compound? We can see that it is CH2, and we have two chlorine atoms. That's an example of halogenoalkane, which means some organic compound is reacting with the PCl5 to make halogenalkane. For this purpose, I will again show my notes. Okay, so again from my notes, you can see here the reaction between alcohols and phosphorus halides. So when there is a reaction between alcohol and PCl5, we get the substitution of chlorine instead of the OH. This OH is now substituted by the chlorine, and we have the halogen alkane formed here. So in our question, we have two choline atoms attached here, which means the organic compound will definitely be of alcohol type, but it would need to have two OH groups. There should be two OH groups here. So the type of the compound must also have two carbon atoms. So I can consider here that there shall be CH2, two carbon atoms, and then one OH group on one side, which will be replaced by the chlorine atom, and another OH group on the other side, which will be replaced by other chlorine atom. So the structure which we can write here would be the same: OH, CH2, CH2, OH. This is the structure, or you can also, instead of this, you can also put the skeletal formula. The skeletal formula is like this: OH, like this, that represents one carbon atom. This intersection represents another carbon atom, and then OH. That's the skeletal formula of the same compound. Then next question: 1,2-dichloroethane reacts with NaOH to produce unsaturated compound, which is this compound. In reaction 7, state what is meant by unsaturated. You have studied in O levels, IGCSE, that unsaturated means having carbon-carbon double bond between carbon bonded with carbon, or having multiple bonds. That multiple bonds will definitely contain carbon-carbon triple bond. So carbon-carbon double bond or multiple bonds between carbon in means by unsaturated. State the condition for reaction 7. Okay, so this reaction between halogen alkane reacting with the alkali to make this compound along with water and NaCl. Now, if you compare this product, this organic compound, this organic reactant with this organic product, you can see that one chlorine is removed and one hydrogen is removed, because we had 4 hydrogen atoms here, but here we have 3 hydrogen atoms, which means there is a loss of one hydrogen and a chlorine atom. There's a loss of HCl. There's a loss of HCl from here by the halogen alkane compound. Now, which type of conditions is required for this purpose? We have NaOH, but what else do we require here that can be seen from the notes? All right, so here the reaction, you can see here the elimination reaction of halogen alkanes in the presence of the alkali and also in the presence of the alcohol. This type of reaction is given. So elimination reaction when we have alkali along with the ethanol. You can also put alcohol here. So alcohol along with the alkali, alcohol plus alkali will give this elimination reaction to remove the hydrogen and bromine. The hydrogen has reacted with the OH to make water, and the halogen is removed separately. So this type of reaction is given by the halogen alkanes. So in our case, that is happening in the same way. So the condition required, along with that, we also need to provide the heat. So the reaction is carried out in the presence of the high temperature, and alcohol. So I will write ethanol, or you can also say the alcohol acting as a solvent plus high temperature. So these two conditions are required for the reaction, or you can also say heat instead of high temperature. Now the next question, number D. Now question number D, compound D contains carbon, hydrogen, and chlorine only. Figure 1.2 shows the mass spectrum of D. We have this mass spectrum in which we have the abundance on the y-axis and M by E on the x-axis. We have provided two peaks, 1 and 2. Explain the relative abundance of peaks 1 and 2 in the mass spectrum in figure 1.2. All right, now we have to explain what is being represented by 1 and 2 over here. We can see here that the D is basically a compound which contains carbon, hydrogen, and chlorine only. And then two peaks are represented. One peak is at 100%, and the other peak, if we closely look over here, at which point do we see point number 2? At which point do we see D? At which point do we see the peak 2? So if it is 30 over here, this is 30, and it's slightly above, but not touching the midpoint of this. It's not touching this point. Instead, it is in between this value and this value, which means it is somewhere here. This goes to 33. All right. So it is 33% over here, and the above the peak one is at 100%. So peak one is at 100%, and peak 2 is at 33%. If you recall from the topic of the mass spectrum in last chapter of analytical techniques or the analytical chemistry, we saw that the chlorine atom can show two isotopes, chlorine 35 and chlorine 37. The chlorine 35 is present by 75% and chlorine 37 is present by 25%. If we take their ratios, 25 divided by 25 divided by 25, we get 3 ratio 1. So this 3 ratio 1 is being indicated here. If we look closely here, this 100% and this 33% means the same thing. It is also 3 ratio 1. If you multiply 33 with 3, you get 99, which is closer to the 100%. So basically, this peak 1 is being shown by chlorine 35, and this peak 2 is represented by chlorine 37. Their percentages are basically their isotopes, chlorine 35 and chlorine 37. So what shall we write over here in the answer? We will say that direct abundance is 3 ratio 1. In other words, the relative abundance is basically, we will say 100 ratio 33%, or you can also write it is 3% ratio 1%, or you can also write 3 ratio 1. So first you will write like this. It is like this ratio, or you can also write 100 ratio 33, and then you will say that why is it there? Why is it like this? Because it is because of the isotopic abundance of chlorine. There is chlorine atom there. This 3 ratio 1 is because of the presence of the chlorine atom, isotopic abundance of chlorine. And one more thing which you should remember, we are getting only 2 peaks here, which means there is a presence of only one chlorine atom. There is only one chlorine atom. If we look at the notes here, we have the two different combinations. We can have one chlorine atom to give you two peaks as 3:1, or you can have a compound containing two chlorine atoms. If the compound contains two chlorine atoms, then you will have three different combinations. A peak at m plus, another peak at m plus 2, and third peak at m plus 4, which you can see from the spectrum like this. This is a mass spectrum when we had only one chlorine atom to have two peaks at 3 ratio, at 1 ratio, at 35, at 37. But if we had two chlorine atoms, then there would be three peaks at m plus, at m plus 2, at m plus 4 peaks because of 35 and 35 to give 70, 35, 35 gives 70, this gives 35 and 37, and this is 37 and 37 to give 74. So in our question, we just have one chlorine atom, that's why we had only two peaks. So we will also write isotopic abundance of chlorine because, or you can also say and, D contains one chlorine atom. So that's the smallest answer. If you can condense the answer, that relative abundance is 3:1. Isotopic abundance of chlorine, D contains chlorine. D contains only one chlorine atom. That's the right answer. Now, to suggest the structure of D. So, structure of D means you have to deduce how many atoms of these three elements must be there in compound D. We had carbon, hydrogen, and chlorine. So these three are identified, but how many of them are there? For this purpose, you need to look at the largest value in the mass spectrum. The largest value on the x-axis of m by E means it indicates how much mass of the compound is there. So it is 62. So that's the highest value. But you should remember that 62 goes when chlorine is 37. And when it is chlorine 35, then it would be 60. For chlorine 35, the mass will be 60 because its value is 2 units less. All right. Now we have to do some calculations to find the structure of D. We said that it has carbon, it has hydrogen, and it has chlorine. These three elements are there, but the value should give you 60. Okay, I'm going to take out the value of chlorine, which is already understood. There is only one chlorine atom. It is identified already. It is understood that we have only one chlorine atom. That one chlorine atom of isotope 35 will give you mass of 35. So simply take minus 60 minus 35. This gives you 25. So it means we are left with carbon and hydrogen to have a combined mass of 25 now, because 35 is already taken by the chlorine. The remaining 25 mass should go for carbon and hydrogen. Carbon, as you know, has the AR value of 12 and hydrogen's value is 1. So if I do the combination, if I write two carbon atoms, that will give me 24, and I will add one value from the hydrogen to make 1. So this gives me 25, which means I have one hydrogen atom and two carbon atoms. So that's the only way I can say. If I do the other way around, if I say one carbon is 12, then to make it 25, I need to add 13 hydrogen atoms. Now that's impossible thing. We cannot have 13 hydrogen atoms with one carbon atom. But on the other hand, we can have two carbon atom and one hydrogen atom. So 2 carbon atom and 1 hydrogen atom along with 1 chlorine atom. So how it would look like? So let's say carbon that bonded with another carbon. Now that carbon is bonded with chlorine and hydrogen is bonded with another carbon. So hydrogen valency is completed, chlorine valency is completed with one single bond, but carbon valency is not completed, which means carbon would must have three bonds between them. That is called triple covalent bond. You should remember it is a triple covalent bond. That's how we can have this type of the structure. Now that is the structure of the compound D. That's the structure of compound D. Hydrogen bonded with one carbon, which is bonded through triple covalent bond with another carbon, and then hydrogen. Or if you don't want to write the molecular formula, that's also right. We will write C2HCl. That's also acceptable. Now, next question. Question number 2. The group 2 elements show metallic bonding. Define metallic bonding. Now, that's a simple question. Metallic bonding, as you know, is electrostatic force of attraction, electrostatic force of attraction between positive metal cations and mobile or delocalized electron. And mobile or delocalized electrons. Do not write the mobile cations. That will be incorrect. Mobile cations are not mobile. That is incorrect. Mobile cations is incorrect. And also do not write ions over here. Ions is also wrong because we have only cations over there, but not the anions. There are no anions in the metals. They are just electrons. And those electrons are mobile or delocalized or free moving electrons. Now part B, the group 2 elements form stable plus 2 cations. State and explain the variation in ionic radius of group 2 elements down the group. So as we know that for any group of periodic table, the size increases down the group. So we will write that ions get larger get larger. We do not write the same words again in the answer because it already says down the group. So ions get larger, and then we have to explain. State means how is the trend, and explain means why is that trend. So explain means because we have extra shells of electron because of extra shell of electrons. Now the answer is completed, although we have so much space left, but that is for no use. If you have your precise answer, then you do not need that space. In fact, this two word could also be adjusted in my cross out answer to have me 3 extra lines for space to write my answer. Then part 2, table 2.1 shows successive ionization energy from beryllium. Use table 2.1 to state and explain. Again, we had to state how is the trend and then explain why is that. So the general trend in these values. So what is the trend in these values? And what is the significance of the larger difference between second and third ionization energy? And we have to explain. So we have to state and explain the point 1, and then we have to state and explain the point number 2, both. Okay, so you can see the trend. The trend is increasing trend. The values of ionization energy values are increasing. So ionization values are increasing, that is state, then we have to explain it because why it increases. So you should remember that first ionization means you are removing the first electron, second ionization meaning you are removing the second electron. What is the position of the beryllium in the group in the periodic table? It is present in group 2 and it is present in period 2. Second period, it is present here. Second group, second period, which means it has 2 shells. The nucleus is in the center and then it has 2 shells. So 1 electron is present here. The 2 electrons are present in first shell and 2 electrons present in the second shell. So first ionization means to remove this electron. This is first ionization energy. This, if we remove this one, this will be second ionization energy. If we remove this one, that will be third. If you remove this, that's fourth. So when you remove first, second ionization energy, then what is happening? You are basically increasing the positive charge of the nucleus, because nucleus has 4 protons. They are not being changed. They are not being removed. They are still there. So you're increasing. You are basically increasing because the positive charge to electron ratio is increasing. Protons are increasing and electrons are decreasing because you are removing the electrons, whereas protons still there, or in other words, you are basically increasing the you are decreasing the shielding because less shielding. How is it that? Shielding is because when you remove both electrons of the second shell, then this shell will be removed and then shielding will be decreased because shielding is because of the shells. So when there is less shielding, then ionization energy will increase because of more attraction between the nucleus and the electrons. Greater nuclear attraction by the nucleus on the electrons. And then you have to state the significance of the large difference between second and third ionization energy. Why is that so? Why there is a large difference? Because there's a large gap, the large jump between second, because the third electron, second ionization means you are removing the second electron, third ionization energy means you are removing the third electron. And you should know that third electron would be removed from the inner shell because first and second electron were removed from the second shell, and second shell means the outermost shell, and the third electron is being removed from the inner shell. So large gap is because third electron is removed from inner shell. That's the reason. That's why we have a high ionization energy gap difference between them. Now the next question. Now the next question is part C. All the group 2 elements except beryllium have more than one stable isotope. Beryllium exists as single isotope B, beryllium 94. Describe a distribution of mass with an atom of beryllium. All right, so here we have to describe the whole distribution of mass. So you should know there are 3 subatomic particles in an atom. Those are proton, electron, and neutron. So the masses must be divided by these 3 subatomic particles within the atom. We have to tell how their mass are relatively compared and how they are distributed. So you know that neutrons mass is basically equal to the mass of the proton. So equal masses are being shared by the protons and neutrons. we'll say protons and neutrons are most massive. They are both of the same mass. And what about the distribution, which means their location in the atom? And they are present in nucleus. Then about the electron. The electrons are the lightest. Electrons are lightest or lightmost. They are lightest and present. Electrons are present in shells around the nucleus. Around the nucleus. So that's how we tell how the mass is distributed. Now, next part 2, complete table 2.2 to show the number of protons and neutrons in the isotopes of magnesium. So these are the names of isotopes, and we remember that all the isotopes contains equal number of protons. So for the number of protons, you have to look at the periodic table. So periodic table says that magnesium atomic number is 12, and this 12 atomic number is basically its number of protons. This means it is also its number of protons. Now we go back to the question. So the number of protons are the same in all the isotopes, but number of neutrons will be different. For number of neutrons, you know that we subtract mass number minus atomic number. So that will give you 12, 13, and 14. Now next part, there is an effect of the electric field on the subatomic particles. We have to label the diagram clearly, and we have to show the behavior of neutrons and electrons in the same field, because the protons are there, but not the electrons and neutrons. The neutrons, as we know, they are electrically neutral, so they will move straight in the path, and we have to label. So neutrons, this is neutron, beam of neutrons, and for electrons, the electrons will be deflecting in the opposite direction of protons, but because they are lightest, they will deflect more than the protons. This is how we represent the electrons. Electrons are deflected more than proton because they are lighter than both neutron and proton, and they have opposite charge of proton. Then next question, D part 1, state what is observed when dilute hydrochloric acid is added to separate sample of barium oxide and barium carbonate. Okay, so reaction is between barium oxide, BaO, and HCl in the first case. So barium oxide is basically a solid. So solid will definitely react with the acid, and this would convert into the barium oxide plus HCl. Reaction will give you barium chloride plus water. That's the reaction. Barium oxide is solid, HCl is aqueous. Barium chloride is an aqueous because it is very much soluble in water. All the chlorides are soluble except for silver chloride, lead chloride. These are forming precipitates in the solution, but not the barium chloride. And water is definitely a liquid. So the solid form of the barium oxide will be dissolved. Solid dissolves or disappears because of this reason. That's the observation we have to. What is the observation? We are giving the observation here. And then you can also write disappears. And then barium carbonate. Barium carbonate is again a solid, but the reaction is now different. The reaction between barium carbonate and water, HCl. Now, metal carbonate plus acid gives the barium chloride. Again, you will have the barium chloride plus carbon dioxide plus water. Now here, barium chloride is again soluble. Barium carbonate is definitely solid. Again, same observation can also be written here. But one more difference is the presence of carbon dioxide, which can be observed in the form of the effervescence. So you will need to indicate observation in terms of the bariocarbonate solid and in case of the bubbles of gas of carbon dioxide. So you will write effervescence plus solid dissolves and, or you write and solid dissolve, because there are two clear observations here. The observation in terms of barium carbonate and observation in terms of the carbon dioxide. Now, our next question is, write an equation for the reaction of strontium with an excess of cold water. So it is basically the reaction of group 2 metal with water. So for this purpose, I will go back to the notes and see how the trend of group 2 metal with water is. So as we go down the group, the reactivity increases with the water, and within that, magnesium, on the other hand, produces two different products. When it reacts with cold water, it produces magnesium hydroxide. When it reacts with hot water, it produces magnesium oxide. But since down the group reactivity increases, so the elements below magnesium will all produce hydroxide. They do not produce oxide, they only produce the hydroxide. So within that, strontium and barium both have the similar property. They both produce a metal hydroxide. So we need to give the same answer here by providing the equation. So strontium reaction with water will produce strontium hydroxide, and we have to add the hydrogen gas as well. So hydrogen gas is also produced along with that, and then balance the equation by putting 2 over here. So hydroxide along with the metal reaction with water produce hydroxide plus hydrogen gas. State the variation in solubility group 2 sulfate down the group. So for this purpose, I will take back to the notes, and here we see the trend of the solubility of the sulfates down the group. So it is said here, the solubility of group 2 sulfate decreases down the group. Why was that? Because of the presence of the protective layer of sulfate on the metal. So we say that decreases down the group. So it decreases because down the group is already mentioned here. We just say decreases down the group. Then next question, number 3, the halogens, chlorine, bromine, and iodine show the trends in chemical and physical property down the group. We have these. We have to complete the table 3.1. So bromine, we have to state the color of the bromine and the state of the bromine. So what is the color of the bromine? For this purpose, I will show the notes. Here you can see that bromine color is considered to be dark red, orange brown, or red brown. So you can write any of these names in the answer. I will write brown over here because brown is mentioned over here. Over here 2 times brown is mentioned. So I will consider brown color in my question. So it is brown, and state as already known that bromine is basically the liquid form. It is present in the liquid that is mentioned below it. So it is liquid. What about iodine? The color of iodine in the solid, because we had to tell in the room temperature. At room temperature, iodine is in the solid form. So the color of the solid of iodine is gray or black. So I can write the same answer here, or you can also write silver. So it could be silver, it could be gray, it could be black, and it is solid. Now we have mentioned both the colors and the physical states. The next part is the bond energy in table refer to the excess bond. Explain the trend in the bond strength of excess bond in the halogens. So bond strength is represented by bond energy values. So you can see that moving from chlorine to iodine down the group, the value is decreasing. We have to explain that trend. We do not have to give that trend because trend is already clear from here that it is decreasing trend, but we need to explain that trend. So the reason for this is that the atoms are increasing in the radii down the group. So atoms radii increase, their radius increase down the group. When the radius increases, then the overlapping of the atom becomes diffuse time or weaker. So weaker or longer bond is there. Longer bond means longer bond length. Yes, there's longer bond length have weaker bond attraction. So the attraction of the bond is weaker, and there is a greater bond length between the atoms as the size increase. Having large size of the atom have the weaker bond or have the longer bond length. Then B, explain with the use of an equation how chlorine gas is used in water purification, state the role of the active species produced. So for this purpose, I have to include the reaction of the chlorine with the water. So for this purpose, you can see the reaction of the chlorine with water over here. All right, so here's the reaction. When chlorine reacts with the water, we have the formation of the HCl and HClO. Now this HClO is basically considered to be the bleach. It is basically the bleach which sterilizes the water by killing the bacteria. So this is the reaction. Cl2 plus H2O produce HCl and HClO. We have to explain with the use of an equation. So Cl2 plus H2O produces HCl plus HClO. Now state the role of the active species produced. Role of the active species produced. This is the active species HClO. HClO, what's the role of this HClO? Or you can also say HC, just ClO negative. Either write ClO negative or write HClO. It basically kills the bacteria. For water purification, you need to write the role. That's not the role, but that's the basic behind the water purification, that it kills the bacteria, which you have seen from here. When HClO is produced, this HClO acid or hydrocarbon is a weak acid which sterilizes water by killing bacteria. So that's how we tell the answer. We give the answer. C part, the sodium halides in table 3.1 also showed trends in chemical properties. Identify the sodium halide that reacts with concentrated sulfuric acid to form H2S. So which of the halide from this table will produce the H2S? Okay. Sodium halide would be either this one, this, or that, sodium iodide. For this purpose, we need to again check my notes. So if you go back to the reaction of the sodium iodide with the sulfuric acid, then you can see there is the formation of H2S over here. So H2S is produced when the sodium iodide reacted with the sulfuric acid, because that reaction was carried forward, and then we had the reaction of the HI with the sulfuric acid that produces the H2S. So from the table, the sodium halide is a sodium iodide. Then identify the sodium halide that only undergoes a Bronsted-Lowry acid-base reaction with concentrated sulfuric acid. So if we go to the reaction between the sodium chloride with the sulfuric acid, here, sulfuric acid acts as an acid here, directing the proton to the chloride to produce HCl. There are no changes in oxidation number, so it is not a red oxidation. So reaction between sodium chloride and sulfuric acid is only the acid-base reaction in which the H2SO4 acted as an acid, and the sodium chloride will definitely be acting as the base. That's how we can say that it is only the acid-base reaction. So we will write NaCl over here. Now the next part is a student adds a few drops of silver nitrate to solution of NaBr, state what is observed. So definitely that will produce AgBr. And what is the observation of AgBr? It is providing the cream or off-white color precipitate. You can write cream, PPT, or you can write off-white, solid, or PPT whatsoever. The next is D. Iodine monobromide, IBr is the dark red solid that melts near room temperature. IBr reacts with propene. The mechanism for this reaction is the same as the mechanism for that of HBr with propane. Identify all the intermolecular forces that exist between molecules of IBr. So, molecular forces which must be present between the IBr and all of them. For this purpose, you should remember the electronegativity values. I will show the electronegative values for the IB for iodine and bromine from my notes. So from this table, you can see the electronegative value for bromine is 2.6 and for iodine it is 2.5. There is a difference of only 0.1 between them, which means that iodine will have partial positive charge on it and bromine will have partial negative charge on it, because iodine has smaller value. It is it has larger, well, it is smaller value, yes. Iodine has 2.5 value and bromine is 2.6 value. So because of this difference, we can see that the type of the force between them, the intermolecular force, not the intra. Do not give the answer in terms of intra, because intra includes covalent, metallic, and ionic. Do not write this. That will be incorrect. You need to give the answer in terms of inter. So inter means we have the permanent dipole forces, or PDPT force. You can either write the complete name of this type of force, or you can also write the short form, which is PDPT force. And it will also have the IDID force, because IDD is that type of the force which is present for every type of the molecule. IDD means instantaneous dipole induced dipole force. Instantaneous dipole and induced dipole force. So this type of force is present for every type of the molecule, that could be polar or it could be non-polar. And this IPR is very weakest polar, because very small difference in the electronegative values. Name the mechanism involved in the prediction of IBR with propene. Now, it said that the reaction of IBR was similar as that of the reaction of HBr with propene, which means HBr reacting with the propene. And what is the structure of propene? It is CH2 double bond CH and CH3. Now, when HBr reacts with the propene, then definitely H will go on one carbon atom and bromine will go on the other carbon atom. But this reaction is followed by the attack of the hydrogen, sigma positive hydrogen on the double bond. The sigma hydrogen of the HBr attacks on the double bond, and that is called the electrophilic, because H positive is electrophile. So electrophilic, that's the reaction by electrophilic. Along with that, it is the addition reaction. You can see from my notes the electrophilic addition of an alkene with the HX. So ethene reaction with HBr produces C2H5Br, and that is the electrophilic addition reaction. So that's why this is the type of this reaction. The reaction of IBr with propene forms two structural isomers. Draw two structural isomers shown by these molecules. So I need to have two isomers from here. For this purpose, I will first write the reaction CH2 double bond CH3 reaction with the IBr. Now, in one case, the I will go on this carbon and bromine will go on the other carbon. And in the other case, the iodine will go on the first carbon and the bromine will go on the next carbon. These will produce two different isomers. So the one which are indicated by the blue arrows, I will first write the structure formula of that compound. So CH2 bonded with the bromine, and then CH bonded with the iodine, and then CH3. And the second, which are labeled by the red arrow, so CH2 bonded with the, I have mistakenly shown the same thing, same time. As I said, that in one case, the iodine will go on this CH3 and bromine will go on this carbon. And in the second case, the iodine will go on this carbon and the bromine will go on the first carbon. Now for the first type, I need to represent the same. So for the first type, which are represented by blue arrow, this will be having the iodine. This carbon will have iodine and this carbon will have bromine on it. And the other case, the first carbon will have the bromine on it and the second carbon will have the iodine on it, like this. This is the structure formula. So I have included both type of the formulas here. You can, for your own ease, you can also represent them in terms of the skeletal formula or not. So two structural formulas here. Identify the type of the structural isomerism shown by the molecules in D type 3. Okay, so which type of isomer do you see here? We can see that the position of the iodine and bromine are changed here. In one case, the bromine was in the center, and in the other case, the iodine was in the center, which means there is just a change in the position of the function groups, because these are basically the function groups. So you will write here, these are basically the positional isomerism because of change in the position of the function groups over here. The next question, part 5, explain why the two structure formula do not form in equal amounts. Why they do not form in the equal amounts? Okay. Over here, we will apply the principle of the Markovnikov's Nico addition rule. According to that, the positive part goes to less substituted carbon, or you can also say stability of carbocations. So the one which is most substituted carbocation is more stable. So R bonded, 3R bonded with the partial positive carbon is more stable than 2R bonded with the carbocation, which is more stable than 1R bonded with the carbocation. So according to that, the less the positive part of the compound is basically iodine here. We said before that iodine has less electronegative value, which means that iodine is the partial positive part over here. So this would go to that carbon which is less substituted. So less substituted in the propene molecule is the CH2. So iodine must go over here according to this rule. Iodine must go over here and bromine must go on this carbon which is more substituted because the central carbon is bonded with two alkyl groups. This is one alkyl group and this is the other alkyl group. So bromine, which is more negative as compared to iodine, must go on the central carbon according to stability of the carbocation. So that's the reason that IPR is basically the electron is polar compound, and we will also say IBR is a polar molecule. IBR is the polar molecule, and then the I positive attacks first according to Markovnikov, according to the reaction type, it attacks first. So the one which attacks first will produce a different product than the other. And also the secondary carbocation is more stable because the reaction of this is providing us secondary carbocation. When you will see here during the reaction, when only the iodine has attacked, then the iodine will attack on the first carbon, that will produce carbocation on the second carbon. There will be no bromine at that position. This second carbon will have two alkyl groups attached on it. That gives secondary carbocation. This is a secondary carbocation. This is the right way of showing the reaction. So secondary carbocation is more stable than the other reaction, which will be the primary carbocation. Now the last question of this paper. Question number 4 shows compounds J to M, each of which contains 4 carbon atoms. Table for performance shows details of tests on J to M. In each test, only 2 compounds give a positive result. Complete the table. All right, here we have the 4 compounds, and we have to complete this table. Acidified K2CO27 potassium dichromate reaction with the J and L. So J is aldehyde, K is ketone. This is aldehyde. This is ketone. This is alcohol. This is carboxylic acid. Okay, so reaction of potassium dichromate with J and L will definitely be positive result because it says here it is a positive result. So during that, the observation is that it is previously in the orange form, but after the reaction, it will convert into green form by chromium plus 3. So orange to green color. Now there's a positive observation, orange to green. Now the next is alkaline I2 reaction with the some compound to give yellow PPT. So which compound will produce alkaline will give this positive result. So we know that only those compounds which have this group in that will give the positive result. CH3 bonded with carbon, which is bonded with the CH and OH in terms of alcohol, this would be the compound, or CH3 carbon bonded with the this. If this in terms of alcohol, this is in terms of alcohol, and this is in terms of the carbonyl group. So if these groups are present in the compound, then these will produce a positive result. So we need to see which groups will include these groups, which compounds. So we do not have such group over here, so this will not be the one. We do have the carbonyl group in this case, so that can give the yellow PPT. And the alcohol does have CH3 over here, that will also give PPT, and this carboxylic acid will not have this group. So K and L. So both K and L will give this result, K and L. The next is reaction of some compound or some reagent with the positive result of orange PPT by the J and K. So J and K, we can see here that J is an aldehyde, K is a ketone. All right, aldehyde and ketone, and the observation is orange PPT. So that reagent which reacts with both aldehyde and ketone, and the color is the formation of orange PPT. So that is only 2,4-DNPH. That's the reagent which produces this observation with aldehyde and ketone. The next is sodium. Reaction of sodium with the which compound? We have to tell what should be the observation of the positive result and which compound will give this result. So sodium can react with the alcohol and with the carboxylic acid. Sodium will react with alcohol to replace hydrogen with Na, and over here it will replace this hydrogen with Na. But it cannot give reaction with the ketone, it cannot give reaction with the aldehyde, that cannot give the reaction. So both L and M can give this reaction, the alcohol and the carboxylic acid. And what is the observation? Basically, during observation is that there is a formation of the hydrogen gas. The H2 is produced both in the alcohol and both in the alcohol and in the carboxylic acid, and that observation is basically the effervescence. So we will write effervescence over here. Effervescence is observed here. Now the last part of the question, B, complete K reacts with SCN in the presence of the KCN catalyst forming N. Complete the figure for P22 to show the mechanism for this reaction. Include charges, dipoles, non-pair electrons, and curly arrows as appropriate. So the reaction is between the CN with this compound, which is ketone. So we should know that this carbon is positively charged over here. The oxygen is negatively charged. Now this non-pair will be attacking on this positively charged carbon, and as a result of this double bond will now break heterolytically to take the electrons on the oxygen atom. So I'll write H3C bonded with the carbon, which is now oxygen, singly bonded oxygen, negative charge on it, and then C2H5 over here, and this is bonded with the CN like this. Now this is the N. Identify the class of compound of which N is a member. So N is this compound and it has CN group and the OH group both. So we will write it belongs to the hydroxynitrile compound. It belongs to hydroxynitrile compound. The part 1 is still incomplete. I need to indicate the lone pair on this oxygen atom. There are definitely 2 lone pairs, and then this, how is it converted into the OH? It is because the hydrogen of the SCN will now be reacting over here. So this oxygen ion will be attacking on the hydrogen ion of the HCN in the second step. When it does, it will then convert into the OH. And in the first step, uh, the Cn negative was acting as a nucleophile to attack on the positive part carbon of the carbonyl group. So we have indicated all the charges on the carbon, oxygen, and nitrile group, and then in the hydrogen ion, along with their arrows. 3. And has a chiral center. Explain what is meant by chiral center. Okay, so chiral center is such a central carbon atom which is bonded with 4 different atoms or group of atoms. Carbon bonded with 4 different atoms or groups of atoms. It is that type. We can also say it as chiral carbon or asymmetric carbon. That's also a different name of the same, which is bonded 4 different atoms or group of atoms. So that's how this paper is now completely solved. I hope I have explained each and everything in detail. If you still have any queries, you can leave the comments below in the comment section, or you can reach me out on the WhatsApp number as mentioned over here for any other queries. So I will meet again in my next video with another paper. Till then, take care and Allah Hafiz everyone.